Okay, so all of you must be watching movies, and whenever a movie comes, in theater, we generally look for its reviews, right? There are online reviews, there are newspaper reviews, right? And we decide, right, based on the reviews, whether to watch the movie or not. So here we have simplified the problem. Generally, in real life, we have different stars, right? 5-star reviews, 4-star reviews, 3-star reviews, and so on. But here we will simplify it into two categories, whether the review is positive or negative. Got it? So something like, if movie is getting more than 3-star, it is positive rating, less than 3-star, it is negative rating or something like that. Okay. So we are going to take a data set of reviews, and each review is labeled as 1 or 0, 1 being a positive review, 0 being the negative review. Okay. So we are going to download the data set. We'll also need a pre-trained model. There are a bunch of pre-trained models that are available. I'll talk about 3 different choices of pre-trained model and demonstrate using one model. And then I'll specifically pinpoint what you can modify in the code, and also try a couple of other models or a couple of other options that are available. And as the best practice that we are following in the code, we will be using pipeline construct. In order to use pipeline construct, we will have to create our own transformer class for pre-trained model. So I have written a sample of that particular code as well. So I'll also walk you through that particular code. So without further ado, what I will do is I'll bring up the collab and start explaining what exactly is happening. And then what you can do is part of the pieces in collab you can copy as they are for your own task, and then experiment with it. Okay, so let me bring up the collab. Okay, is the content visible to all of you? Is the font okay? Okay, I'm taking a minute of a break to just check whether everything is okay. Is font okay?
Yes, sir, it's okay. Perfect.
Okay, you can see it clearly, right? Okay, because this will be part of the recorded session, so I want to make sure that everything is perfectly
Yeah,
fine.
it's good, sir.
Okay. Still, I have gone ahead and increased font size by 1. So let's see. Okay. Um, all right. We'll resume the recording again. So as I was saying, this is a text classification with movie reviews, and it's an example of a binary classification or a 2-class classification problem. By the way, this entire notebook I have not authored myself, but I have taken this notebook, part of the notebook, from the TensorFlow tutorials. That is the attribution I would like to call out. And TensorFlow tutorials does this end-to-end with TensorFlow, but what we have done is we have taken the initial part where we are using the hub model, and then the later part we are going to use sklearn, as we are used to a sklearn model. Okay, so do not worry too much about these TensorFlow details. You can use them as they are for the purpose of this course. Okay, but when you go to, let's say, deep learning course, you can learn about TensorFlow API in more deeper manner. Okay, and just to provide you some idea what is TensorFlow. TensorFlow is a deep learning library, and it has got a lot of neural network building blocks or building blocks for deep learning models. There are models, different optimizers, different evaluation methodology, all pre-packaged and available to you, just like sklearn. Think of TensorFlow as sklearn counterpart for deep learning models. Okay, that much information is good enough for the purpose of this exercise. Okay, and we have what is called as tf.keras API. So I have actually written some part of this text from the notebook as it is, so that you can also see some other text classification guides and things like that. So there is a very nice text classification guide on developer.google.com. So if you're more interested in understanding deeper, deeper understanding of text classification, you may visit this particular link, which I have written for more curious students and audiences. But for many of you, you need not even do this. You can just stick to what we are covering in this course. That is good enough. So we are going to use tf.keras for loading this model from TensorFlow Hub. I was talking about TensorFlow Hub. It's a library and platform for transfer learning, and it has got a repository of pre-trained models. We'll see how to load models from TensorFlow Hub in this particular collab. Okay, I'm already connected to a runtime, and we'll go on, running cells. So here, as a setup process, we are going to do a bunch of imports like NumPy for any of the numerical Python computation. We are going to use NumPy. Then there are a bunch of TensorFlow related imports like TensorFlow underscore hub, and TensorFlow underscore datasets. TensorFlow underscore datasets is a nice package, just like scikit-learn datasets, right? We have studied different datasets that are available in scikit-learn. In the same way, TensorFlow has pre-packaged many standard datasets. So, whenever we import TensorFlow underscore datasets, a wide array of different datasets are available to us. Okay. Matplotlib is actually not required for this particular collab. I'm going to delete that, and then we will just print few things like TensorFlow version, and we are going to anyway do eagerly execution. This is TensorFlow 2.0, and hub version also we are printing, and for this particular purpose we don't really require GPU, so I'm also going to delete this particular line. Let me run this. You can see that we are using TensorFlow version 2.15. We are going to execute in eager mode, and her version is 0.16. So a small note about eager mode. So in TensorFlow 1, what used to happen is that we used to first tell TensorFlow what computation we are going to do. That phase used to be called as defining a computation graph. And then we used to run this computation graph under a session, right? So that was in TensorFlow 1, which many people found very unintuitive and very non-Pythonic. So in TensorFlow 2, what they did is they enabled eager mode execution. In eager mode execution, what happens is that as we are typing in the commands, TensorFlow maintains that particular graph internally. We don't have to do this two-step process where we have to first define the graph and then do the training and things like that. Now we can pretty much use TensorFlow like any other Python library. Okay, so that is about eager mode. Do not worry too much about it. I just thought of giving a historical reference to what eager mode is. Okay, we are going to download IMDb dataset. IMDb is, I think, international movie database or something like that. IMDb is also a famous site. It has got all the information about different international movies. So if you are a movie buff, you can go to IMDb, read about movies, right? About a plot of a movie, who are actors, who is director, who is music director, everything about that movie will be there in IMDb. It also has reviews. So, this TensorFlow dataset contains a bunch of IMDb reviews. And, this dataset is available in TensorFlow dataset. So all that we have to do is we have to do tfds.load, just like we do dataset load in scikit-learn, there is tfds.load. And again, the good thing is that you can also see the documentation for this here. Right, as you hover over this particular thing, you get to see the documentation. So here we are going to, load IMDb underscore reviews. We are going to use two splits, train and test, which is already done in this data set. So which we don't have to really now worry about it. We have set batch size to -1, and we are going to use this for supervised training. So we have set as underscore supervised flag to true. So now we have train data and test data as part of the load function returns train data and test data. And train data, then we convert this data set into a NumPy data set and into NumPy array. And from this data, we get basically uh, a tuple or two different things. One is train underscore examples, which has got reviews, and train underscore labels, which has got the label for every review, right? As I said, this is a binary classification. A review will either be positive, represented by label 1, or negative, represented by 0. And we have 25,000 such kind of reviews. You can see the shape, right, of ND array, 25,000 commas, comma. So there are 25,000 reviews here, and each review has a label. So you can see that for train underscore label, we also have similar kind of a shape, 25,000, right? So there are 25,000 labels here and 25,000 examples. Same way in test dataset also there are 25,000 examples and 25,000 labels. So there are overall 50,000 reviews that are available in this dataset, which is equally split between training and test. And even within this, right, reviews, the number of examples of class 1 and class 0 are balanced, meaning that both class 1 and class 0, right, positive and negative reviews, there are equal number of representation in this dataset. So this is that way a simpler dataset to work with. We'll run this. Now, if you are loading your own dataset, it will be great if you can actually convert it into a TFDS format. If you can convert your dataset into TFDS format, then you will get to use this as it is. Otherwise, you can also use other formats like CSV or some such kind of things, and you will have to read your data using those formats. And make sure that you have one NumPy array that has got the statements or the article, whatever, right? Whatever is your content, the text content, that should be there in one array. So one entry in the array is your entire text content of that example. Got it? So if you have 10,000 such examples, you will have array of size 10,000, where each record in the array will have the entire text content. And then we need to also have then 10,000 labels, right? One label for every example. Got it? So this is how you can repurpose this code for loading any of your data sets. Got it? Any questions so far? Is all good? Okay. Thanks for the feedback. Thanks for the emojis. We'll continue. So this is very important to know how you can use this particular repurpose this code base for your own purpose. Okay. Now we'll take a moment to explore the data. Let me run this. And this piece of code, what is it doing? It has printed the number of entries, right? There are 25,000 training entries and 25,000 test entries. And you can see the way it is done. So we use print statement, we say training entries. Then, we left a placeholder. Again, for test entries, we left a placeholder and we used a format function on this string. And we gave the values for this placeholder. The first value over here is length of training examples. This will get filled up here, and length of test examples will get filled up over here. That's how this particular string is generated using the print function. Okay, and if you want to print first 10 examples, this is easy, right? This is just like any other Python program, Python construct for reading entries from array. So if I run this, we will get first 10 entries. Okay. So you can read them, right? So this is yeah. This is one review. This is another review. Okay. All right, I'll take a question. No questions, right? Okay, I got distracted with the ping. Yeah, so you can read the review, right? This is a kind of film for a snowy Sunday afternoon when the rest of the world can go ahead with its own business as you descend into a big armchair and mellow for a couple of hours. Wonderful performances from Cher and Nicolas Cage, as always gently row the plot along. There are no rapids to cross, no dangerous waters, just a warm, witty paddle through New York life at its best. A family film in every sense and one that deserves the praise it received. Okay, so this seems like a positive review, right? You can read this and you can see that this is a positive review. Okay. All right. So, these are some reviews that first 10 reviews that we have printed here. So you can go through the reviews and you will be able to figure out whether review is positive or not. Okay. I will also print first 10 labels, and you can see that in first 10 reviews, most of the reviews are negative. There are only 3 positive reviews and 7 negative reviews. Okay, you can see the positive labels to uh, 3 reviews and rest of the others are 0 or negative reviews. Okay, that was a very simple data exploration part. So this is how you generally do data exploration in text. You print bunch of examples, you go through them, and it is important to, one of the advice that I would like to share here is you should go through each of the example and get understanding of how the reviews are written, and then also look at the labels in the training set and see and you can judge yourself, right? Whether the reviews that you read and the label that is given, and do they make sense? Correct? All right, so let's read one negative review. So this is last, right? Sure, this one isn't really a blockbuster, nor does it target such a position. Dieter is the first name of the quite popular German musician who is either loved or hated for this kind of acting. And that's exactly what this movie is about. It is based on autobiography. Dieter Bohlen wrote a few years ago, but isn't mean to be accurate on that. The movie is filled with some offensive content, which is either amusing or dumb. It depends on your individual kind of humor or on you being a violent fan or not. Technically speaking, there isn't much to criticize. Speaking of me, I find this movie to be an okay movie. Okay, so not a great review. So they have given 0 rating, but this could be, this could be hard, right? I mean, while reading this review, I thought sometimes that this is like a positive review, but towards the end, probably this movie is an okay movie. Is kind of a, it gives you vibe that probably the review is negative. But this could be a challenging review for our model. Okay, so so you should read through reviews and understand what kind of reviews are they. You can also get an understanding of how big are the reviews, right? What is typical length of the review? So that type of exploration also you can take up. Okay. Now let's come to the model building part. And this is going to be important. Any questions? Yes, Naval, that is correct. So we also need to understand sarcasm or mixed text on online forum. That is totally correct. Any other comments, reviews, any questions? Happy to take up questions because now we are going to descend into the model building, which is the most important part. Okay, so I assume that everything is clear so far. Okay, let's move on. Okay, so we'll be building a transfer learning based model for this task, as we said, right? I mean, the whole purpose of this notebook is to demonstrate how transfer learning can be used for text related machine learning task. Hmm. So we will need a transfer learning as a feature generator, followed by logistic regression model in scikit-learn. We can also use other classification models. So there is nothing particular about logistic regression model, but I chose logistic regression model as a simple model which gives decent result for this particular task. And in this example, the input data consists of sentences and the labels to predict are either 0 or 1. This is what we have already seen. Um, so one way to represent the text is to convert sentences into embedding vectors. We also talked about it. And for that, we will be using models from TensorFlow Hub. So there's a model called Google/NNLM in dim50/2. So /2 seems to be the version of the model. This seems to be representing English text. So this model is specialized in English text. So that's why this EN and dim50 means that this particular model generates 50-dimensional embedding vectors. That means for a given piece of text, it will generate 50 different numbers. Okay. So you can try a couple of other options as well. One is again 50-dimensional model, but it comes with a normalization. So in normalization, what it does is it first removes the punctuation marks from the text, and then it calculates the embedding. So when it removes punctuation marks, you sometimes get better coverage of in vocabulary embeddings for tokens on your input text. And then there is a large model which also uses normalization, but instead of instead of generating just 50 numbers, it will generate 128 numbers, right? So this way you will have a model that gives a pre-trained model that gives you you know more number of features for a given piece of text. Hmm. So we'll be using this. I have used this particular model in this collab, but you can uh, try replacing this model with these two models just with a single line change in the code. Okay. So this piece of code is not so important from the our from this exercise point of view, but it will give you an idea how we are going to work through this, right? So we are going to so I have stored the model name in this particular string called model, and we are going to use hub.keras layer. And this hub is basically TensorFlow Hub library that we imported. So we call keras layer function on this. We use the model string, then the input shape is empty. We are going to process data which is of type string, and trainable is true or false. So we are going to use trainable equal to false because we don't want to really train this model. We want to use this simply as a pre-trained model. So we can set trainable to false. And then what you can do is once you define this hub layer, you can use this hub layer and pass the training examples to this, right? So here what I have done is I have passed three training examples, first three training examples to the hub layer. And let's run this. And what you have seen here, what you see here is this particular hub underscore layer function has written a tensor. Now, do not really worry about this word tensor. Tensor is like multidimensional array. And this one is actually a matrix because it has got just two dimensions. So the first one has got shape of 3 because there are 3 examples, and for every examples we have 50 numbers, correct? So this 3 shape of 3 comma 50 means that there are 3 examples, and each example is represented with 50 different numbers. So this is more like a feature matrix that we got, and this particular feature matrix is storing float 32 numbers, and then the number representation is as follows. So you can see that these are first 50 numbers. These are 50 numbers for the first example. Then these are 50 numbers for the next example, and these are 50 numbers for the last example. Getting it? So this is how this matrix is represented. There is this outer bracket. So this is the first entry, first row. This is the second row in the matrix up to this point, and this is the third row in the matrix. Got it? And there are 50 columns. This is the first column. These 0.54 is the value for the first feature, 0.56 is the value for the first feature of the second example. For third example, the value for the first feature is 0.74, or for the first embeddings or first feature. Getting it? This is how this data looks like. Now what we are going to do is we are going to define a pipeline for this. That is our best that is our best practice, right? So I'll skip this particular part for a moment. We'll come back to this, but let's first define a pipeline. And all of you are familiar with pipelines, right? So we are going to use HGD classifier, which is nothing but a logistic regression classifier using stochastic gradient descent. So we import HGD classifier from scikit-learn.linear_model, and we also import make_pipeline. We have done this many number of times in this course, and you're very familiar with this now. So what I'm going to do here is I'm going to define a pipeline with two stages. The first stage is the feature extractor. Second stage is the HGD classifier itself, where we are setting maximum iteration and the learning rate. Okay. All right. Now this text feature extractor is something that we have not talked about. Let's talk about this in more detail. You can see that this text feature extractor is actually a transformer, right? So typically what happens in our pipeline is that we have some pre-processing followed by the classifier, right? So think of this as a pre-processing step. For pre-processing, we use different kind of transformations. So we are going to define a transformation. This is, a custom transformation class. So in order to define this, we have to basically, extend this class from base estimator and transformer mixin. Okay, so this class is inherited from base estimator and transformer mixin, and we have to define basically two methods. One is a fit method and transform method. So for fit method, we have not really done anything, so we just return the self. But for transform, we can also return something like empty, right? Or we can say pass. Also, it's like pass. So in the constructor of this model, we are defining the model name. So if you want to, experiment with other model names, just change this model name to those other model names and rerun this particular part. And then we are defining the hub layer. And hub layer is what you saw here, right? Hub layer converts each piece of text into 50 numbers using this model. So we are defining the hub.keras layer. We are using this particular model name. Self.model means we are using this particular string over here, and rest of the arguments as earlier. And note that enable is set to false. We don't want to really train this model. Then we don't want to really define the fit function. And in transform, we want to basically call the hub layer on the input example. So whatever input text that we'll give, and this is not just one text, but this is an array of text. Okay, so we will give this array of text, we'll pass it to hub layer, and we'll get a feature matrix out of that. So I'll run this. Now we'll run this. So we have defined a pipeline. And now comes the model training part. Okay, I will actually get rid of this code. This is not required for us now. All right, so now what I'm going to do is, you know how to train the model, right? You have seen this multiple times. Now we are in very familiar territory. The transfer learning part is over. All that we'll do is we will take this pipeline function and we'll call fit. And in order to call this fit, we need to give the training examples and the labels. So we give training examples and labels. So note that these are a bunch of text, right? So these are exactly 25,000 um, text instances that we are giving here and 25,000 labels. So what happens is that in this pipeline, first we convert this text into a feature vector and each text into a feature vector. So we effectively get a feature matrix with 25,000 rows and 50 columns. And this feature matrix is passed through the HUD classifier. Okay. All right. So we use the fit model and you can see the pipeline, right? So the first stage is text feature vector and second one is the HUD classifier. And now that the model is trained, what we'll do is we'll evaluate the model. And we have used this earlier, right? Classification report. Classification report gives us, all kinds of metrics, correct? We get precision, recall, F1 score for the classification, and we also get the accuracy here. So you can see that for classable 1, which is positive reviews, we get precision of 0.74, recall of 0.74, and F1 score of 0.74, and accuracy of about 0.74. Okay. Exactly 12,500 examples for class 0, 12,500 examples for class 1. There are total 25,000 examples. Okay. So this is how you can, train a text classifier with transfer learning. So what we'll do is we'll now use slightly more, we'll use this particular bigger model and see whether we get improvement in the performance. Okay, so what I'm going to do is I'll basically just comment this line out and copy this. Okay, so we have to get this. More like a URL path. You can actually click on this and you will get to see the model details. Let's actually click on this. So you can see the model card. So this is the model, NLLM, and NLM is basically token-based text embedding trained on various Google News dataset. So this embedding is trained on news dataset. Okay, and this is called model card, and this is a very useful concept. So model card tells us everything about this model. Okay, it tells you how this model is trained. Okay, it also tells you about different modules in this, like 50 dimensional, 120 dimension. We talked about this, right? 50 dimension ones generate 50 numbers, 128 dimension ones generate 128 numbers, or 128 dimensional embeddings. You can see that there are various versions. There is a Chinese model, English model, German model, Indonesian model, Japanese model, Spanish models. Got it? And it tells you how the input looks like, whether it does any pre-processing, how does it handle out of vocabulary tokens, meaning that we will find some tokens which are not there in our vocabulary. How does it handle it? So model card is, I would strongly urge you to look at model cards whenever you're using a particular model from TensorFlow Hub. Okay, it's a good practice. Now we're going to use this model. Everything else stays the same. Okay, now there is some problem. Let us see. Let's see what is happening here. Okay, let me do this. Let me restart the kernel. Run it from the beginning. Let us also try this particular model over here and see if it works. Okay, this is working. This is giving you 120 numbers. Good. Now, let's see why it is not working over here. Okay, I ran this. I ran this as well. Okay, and I'm running this one. So, okay, so it's still not working. Where is it? Should have worked. Okay, so okay, that was the problem. Okay, we will, edit this recording here now. So I'll again start from. Ideal, this should be self. We should be returning self here instead of pass. Okay. So in order to try the other model, you will have to make a change over here where you set model name to the other model that you intend to use, which is 128 dimensional model with normalization. And then what we'll do is we will again run this. Note that we are also returning self over here and we are not doing pass. This is important, otherwise we get run into some errors. And we'll again create this pipeline. So we are training a pipeline. Pipeline is trained and we'll evaluate the model. Okay, what you see now is the accuracy has gone up to 0.82%. So what happened? Initially, we were using 50 numbers to represent a piece of text. We have taken it to 128 numbers. And now what we are doing is, because of this increase in number of features, we are seeing increase in the accuracy. Do you see this? So this is also consistent with what we have seen in the course, right? So as you increase the number of features, the accuracy goes up in general. So this is what has happened over here as well. Any questions? Any questions? Does anyone has any questions?
Hello, sir.
Yes.
Thanks for the session, sir. Sir,
Yeah, session. I mean, I'll cover a few more things, but yeah, no worries. Yeah, tell me.
okay. So I just wanted to know that is there a way if we can know some of the like we have used some abstraction from Google which we do not know
Mm.
how what features it contains and the what transformations basically it does. So is there a way to know the explainability of this model that we have built? Like,
So these embeddings are abstract. Okay. There is no meaning attached to them. These are bunch of numbers. Okay. Only thing that you know that if there are two pieces of text that are similar, they will get similar embeddings. That's what we know. Okay, but as such, there is not much meaning that we can attach to each of the embedding.
okay, okay, got it. So thank you.
Okay, so what we'll also do is we'll also try to play with the third option that we have and see how the result change, right? We are going to use now this normalization one. So as I told you, we are going to make a change over here. Let me write one more line. I'll comment this line out. We'll copy this part. This is common thing. The first thing that you should be doing is you should be going to this URL and checking out the uh, model card. We checked out the model card, right? Earlier. Okay. Yeah, the same thing. All right. Now we're coming back to this line. Okay, let's run the feature extractor. Let's define a pipeline. We are rerunning this particular part. Okay, there is no change that we made. I mean, we didn't make any change here. Only change that was made was in this particular transformation code, and we'll train the model. And we'll now evaluate on the test data set, right? So you can see that these are test labels, actual test labels, and these are we are calling clf.predict on test examples. This is how we get the predicted labels. Getting it? I didn't mention this earlier, so you can see that we are calling the predict function on the pipeline with test examples. So you know, right? I mean, advantage of pipeline is that all the operations are uniformly applied to training and test set. So we don't have any, difference in the way we applied pre-processing steps to training and test with this. And code is also, I mean, the code becomes very compact using pipelines. So we call predict function on pipeline with test examples. So what happens is that these test examples also go through the transformation process. We generate bunch of features for these test examples, and then we pass them through the logistic regression classifier that was trained, and we get the labels for every test example. We compare these predicted labels with the actual labels, and using classification underscore report function, we get precision recall and F1 score for this. So you can see that earlier when we were using the first model, NLLM dash in dash dim50, that time we were getting accuracy of 0.74. Now we are getting accuracy of 0.77. So, just removing punctuation helped you achieve slightly better accuracy, right? And of course, the best one was with this particular model. So this one, we achieve slightly better accuracy than this, and this one is even more, this is even more accurate. Okay, so this is the best, this model gets us the best performance. So this is how you can, play with different pre-trained models and select the one that works well for you. So this is in some sense also parameter engineering, and also set models that are available there. Right, so you will have to only worry about generating too many numbers. If you generate too many numbers, you might start overfitting. So that is what you need to be watch out. You should be watchful about. Okay, so that's all from this particular session. So a quick recap. So what we did is we took the movie review dataset and we tried to build a classifier. So movie reviews are in English text, and we took that text dataset. We converted that text dataset into a bunch of numbers with the help of pre-trained models, and we saw 3 pre-trained models, and then we used logistic regression classifier on top of these numbers to classify review as either positive or negative. And we use these 3 different pre-trained models, and we saw the effect of these pre-trained models on the accuracy. Okay, so if you are going to do any of the text tasks, you can please copy this particular collab, and all that you need to make change in the way you are reading the dataset. So that is also simple. So you can read dataset which, let's say, is in CSV format, and have train examples and train labels loaded from CSV format. So load that data, then divide this into training and test. Then you will have train examples, train labels, test example, test labels, and we have done this multiple times in the course. And then you should explore it a bit, data, to understand what kind of text is there in the dataset and what are the labels that they're getting. You can also look at the length of each of the text, and then it's all about building the model. You can pretty much retain this code as it is, except for the change of the model. And then use pipelines, train the model, get predictions out of the model, and use classification report to get the quantitative numbers for the task. Okay, so that's all from this session. In the next session, we will be doing the similar exercise of using transfer learning for representing images. Until then, goodbye. Thank you. Okay, all right. How did you find this? Any questions?
So, so the problem of generating embeddings we have been able to bypass by using this. That
No, no,
zero
no.
padding thing that we are doing, that zero padding is still not
Okay.
coming again. I tried that day, but my code runs out of memory every time on Collab and Cattle.
No, this is easier to do it, right? Last time we were trying to do lot many things, and those things are nicely abstracted in this TensorFlow Hub. So with this hub.keras layer, we have bypassed that problem. The keras layer takes care of all the low-level details that we were trying to take care of. So we don't have to really worry about that as as beginners in this particular field. Right, so embeddings are still getting generated, but those embeddings are getting generated in a more user transparent manner, or in a more friendlier manner. I'll share the link to the call. Yeah, go ahead. Any other question?
So one question,
Yeah.
sir, why are we calling this as transfer learning?
Um, we are calling this as transfer learning because it uses some pre-trained model, right? And we have seen there are 3 ways of rather there are the way you do transfer learning. There are 2 ways, right? You can either use the pre-trained model, or the model that was trained on some other task, as it is to generate the embedding. So today we use a model that was trained on Google News dataset, and we use that model to train our embeddings, right? So here we are using that model as it is. We are not making any changes to that model. Second way in which we can take that model, change some of the last few layers or something like that, right? So we talked about some of the fine tuning or using, fine tuning for doing transfer learning and things like that. So here we are using, I call this as transfer learning because we are using, the model that was trained on some other task for generating embeddings, and we repurposed it for our own usage. Does it make sense?
Yeah, yeah. Understood, sir. Thank you.
Okay. Now you can try, you will get access to the notebook. Indranil, can you try it again?
Yes, sir. Now I can access. Thank you.
All right, any other questions? All right. Thank you for your questions and patiently listening. How was the session? Is it accessible? Is it
The
natural
session.
enough? Is it natural enough, or is it too artificial and
So you would need to solve the captcha on the screen for us to know that you are real or it's your avatar speaking.
yeah, exactly. That's what I wanted to ask, right? I mean, this is not too robotic, right? It actually helps to have, some people online, because then you know that you're talking with some real people and not to the camera. All right. So thank you very much. I hope this will be useful for your fellow students. Okay. Take care. Have a nice
Any
evening.
homework, sir? Any potential homework that we
No,
can
you
try?
you can try same thing for maybe try a few other text classification tasks and let me know. So I told you that you can make few changes and pretty much use this as it is.
Hmm.
So get some other text data sets and try to see if you can use this method. Okay.
Okay. Any potential Kaggle challenges where this would be good,
I am
useful?
sure. Let us check it out. No, I mean I don't have anything offhand, but we can go to Kaggle and search for text classification. Oops. For multi-label text classification. Specific. Medical symptom text and audio. You can try this fake news. Hmm?
Okay, sir.
You can try this fake news classification task. Uh, I'm not sure you can. By the way, I mean, don't get disheartened if you don't get great results, because this could be a very tough problem. Just going to share the link. But I really want, Naval, if you can actually try it, or someone else also, if you can try this particular data set and
Sure, sir.
give me feedback whether the whatever I have said in the class, whether you are able to do this with those tricks and tips.
Sure, sir. Will do and reward. I tried the last homework. I thought it's the issue with the memory that the
Yeah,
free.
that's okay. Last homework was not really homework. I mean, I just requested some help from your side
Yeah.
to see. Then there are some other challenges also. There's something called as SMS spam detection dataset.
Yeah. I'm using that only, sir.
So you can try SMS spam detection dataset as well.
Okay. So I guess the first challenge would be converting that to TFDS.
No,
And
no,
once
no, 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 no. Don't go for converting that to TFDS. What I'm saying is that straight away read it in CSV. Hmm?
okay.
And yeah, that's what I'm saying. TFDS would be a lot of effort on your end. It may not work. So what I said, right? What do we need? We just need these four things, right? Train example, train labels, test example, test labels, right? So you first read all the examples and labels with a CSV parser. So simple CSV file, right? Okay, wait, sorry, so here, right? So we have in spam data set, Uh, Here you have V1, right? Spam and ham. So this is label and V2 is actual spam, actual text, right? So you can read this CSV file and just select these two columns. So this is label and this is text, correct? Then what you do is you you basically do some kind of shuffling of this data set and split it into training and test. Okay.
Yes, sir.
Then you get training examples, training label, test example, test label. You get it
Yeah.
and then run with it. Don't convert it into TFDS. That would be too much of work. And we have not talked about it. We have not covered it. So I don't want you to go through that hardship.
Okay. So one more question. So in today's example, you split the train and test exactly into 50-50%, 12,500, 12,500. Was that
Because
intentional?
I actually took the split that was done in TFDS, but you can do 70-30.
Oh, it's not that it will produce good result only
No, no, no,
using
no, no,
50-50.
no, no, no.
Oh,
Idea is to use a lot many examples for training. So 70-30 would work well, 80-20 will also work well.
okay, sir.
But that doesn't mean you should have less example for test. Test should also have good amount of examples so that you get correct estimate of the performance. If you use too few examples in the text, then that's not a good estimation of the performance of your classifier.
Yeah, I agree.
So is the recipe clear? So you will read this SMS text dataset in CSV format. Okay.
Yeah.
Shuffle it, do random shuffling of it, right?
Okay.
And then take first 70% examples as training, later 30% examples as test. And then from there you split, right? You say that what is training label, what is training text, and things like that. So do whatever way that is convenient. Hmm? And
Yes, sir.
let me know. I mean, what I can do in the next class is that first I'll show how to do it for any generic dataset,
Sure, sir.
maybe with spam or something else. So if you actually do this, share your code snippet with me before
Sure,
the
sir.
class.
Okay, sir. Yeah.
All right, because this is important. See, I mean, you should not. So the way I have set up this particular notebook is that you don't have to make a lot of changes. It should
Yeah.
work out of the box, and
Yeah.
you should not be. You should not. You need not worry about TensorFlow. You should not go to Hub and things like that.
Yeah.
Uh, it is enabling you to process text dataset. That is the whole purpose of this week 11 and 12. You should have enough tools in your toolkit to deal with text, images, audio, those type of data sets.
Yes, sir.
Hmm?
Yeah.
Okay.
Yeah.
All right.